For a concrete example, let's take two vectors which form a basis for R2. The two vectors, u, whose standard coordinates are 1 minus 1/2, and v, with standard coordinates 1 and 2, form a basis, which we'll call script b, for R2. Now, generally, it's common for people to name the coordinate system the same as the vectors. Usually in print, this means that the vectors are bolded and the coordinates are not. Since it's hard to bold in this writing style, I'm going to actually throw in a couple of little arrows over the u and the v to make sure that we do not cause any confusion. So we identify the coordinates as u and v because u tells us how far to travel along the vector u, and the coordinate v tells us how long to travel along the vector v. So when we have this coordinate system, we can construct the UV plane exactly as we would construct the XY plane. The vertical axis of our plane, which we're going to call the V-axis, is the set of all points whose first coordinate is 0. Similarly, the horizontal U-axis is the set of all points whose second coordinate is 0. So you can see here the parallels. The x-axis and the u-axis are analogous. The v-axis and the y-axis are analogous. So geometrically, this new coordinate system rotates the plane counterclockwise, so the line y equals 2x replaces the y-axis, and the line y equals negative 1/2 x replaces the x-axis. So you can see here, I've drawn two lines. One in the direction of the vector v, that's going to be our new v-axis, and another which is perpendicular in the direction of u, which will be our new u-axis. Changing our coordinate system is the same as simply rotating our picture. So in the UV plane, the vector v now points straight up, and the vector u points to the right. In this coordinate system, we can think about pairs of numbers. So let's think about how we would identify the point 4, 3 subscripted with a b. In our new coordinate system, we would simply move 4 units along the horizontal u-axis to identify the point 4, 0 subscripted with a b. Next, we would move 3 units in the v direction, which is straight up. So this, in our new coordinate system, is how we would identify the point 4, 3 subscripted with a b. Now, of course, you could have also traveled 3 units along the v-axis, then 4 units along the u-axis, just as you normally would in the xy plane. The behavior is exactly analogous. Now, if we want to understand this particular point in terms of our standard basis, then we can simply express this point 4, 3 subscripted with a b as a linear combination of u and v. So you can see here, in terms of the original standard coordinate system, this is the point 7, 4. So if we take our plane and we rotate it back so that we have the usual xy axis, then we can see that this corresponds to the point which is 7, 4. That is, you would locate the exact point described by 4, 3, subscripted with a b, by moving 7 units along the x-axis, and then 4 units parallel to the y-axis. So this tells us how to move from our new coordinate system back to the standard coordinate system. In fact, we can think about this as a matrix operation. So what did we do? Well, we took the first coordinate 4 and we multiplied that by the vector u. Then we took the second coordinate 3 and we multiplied that by v. So to move from our new coordinate system back to the standard coordinate system, we simply take the matrix with columns u and v, and then multiply it on the right by the vector 4, 3. So in general, if we had a point uv in the coordinates specified by the basis b, then we can express this in our usual xy coordinates simply by taking the matrix u and v is the 2 columns and multiplying it by the vector with the coordinates in it.